Seaborn is used for plotting data in Python. It produces some beautiful visualizations using simple coding structure. Today, I am going to work on a Seaborn exercise using its preloaded Titanic data to plot some distribution plots, categorical plots, matrix plots, and grid plots. Please watch along if you find it interesting or feel free to work alongside if you want to practice these codes too. Let's get started. So first up, we have to import our required Python libraries. So here we imported NumPy, Pandas, matplotlib.pyplot, Seaborn, and we also run a one-line code %matplotlib inline, which is used for showing the visualizations in the Jupyter notebook. If you are doing this in some other IDE like PyCharm, then you can use the code plt.show at the end of your individual codes to show the visualization. Next, we have to set style. Here we will set white grid, but there are different a few other options as well. I will show you those. So here, as you start typing, set underscore, type tab, press tab, and it will open up the signature for this method, set underscore style. And here you can see there are few different types available which you can use for the background, for the visualizations, which are dark grid, white grid, just dark, white, and ticks. So here we are going to use the option white grid, which will be white background with the horizontal and vertical lines. Next, we will set a figure size for all of the plots we will be plotting today. For that, we will be using plt.rcparams. rcparams is runtime configuration parameters, and within that, we will use figure.fixsize. This one, and we will set it to the size we want to run across. So we will start with 6 by 6. These are in inches, so the figures we plot today, we want those to be in 6 by 6 inches. If we want to change the size later, we can always come back to this line and rerun it with different configuration. Next, we have to load the Titanic dataset from the Seaborn, and we will store it as a variable called Titanic. So Seaborn comes with some preloaded datasets like Titanic, Tips, Iris. These are some of the famous datasets. You can always use it without uploading your own data to, to practice on your visualization skills in Seaborn. Next, we will check the head of the data frame and other attributes using the info method. So what we see here, we have all of these columns. First column is survive. Then there is something called P class. This could be passenger class. Then there's sex. Pretty sure that would be male and female. Then there's age, something called SIB, SP, then parch, fair, embark, class. Those could be first, second, third class, who, man and woman, adult male, true and false. So this column is for if the passenger was an adult male, it would be false if either the passenger was female or he was a man but under the age of 18. Then deck, nan are for null values. Then there's something called C, we will see this later. Then embark, town, alive if yes or no, and then alone if they were alone or not. So let's check, let's use the info method to check other attributes about this data frame. So this is a data frame which has a total of 891 entries ranging from the range index ranging from 0 to 890, and in total it has 14 columns as we saw above. Most of these has no non-null values, but some of the columns has some null values. For example, age here, it has over 170 null values. Then there is this column embark which has two null values. Then again deck which has a lot of null values, over 600 null values here. Then again two null values. Also this survive, passenger class, sex, these are integers. Sex is an object which is obviously a string, male or female. Then age is floating. SIBSP is integer, parch is integer, fair is again a float. Then embark is an object, class is category, who is an object. These are all, as you can see, these are all strings here, and that's why it's an object. Adult male is given as true or false, so that is a boolean object. Deck is again a category, given as category. Only some of these have the value, most of these are null objects. That means there's no data available for those. And then we have the others. Now next we will start creating the plots. First up we have to create this plot here. So we need to be careful not to plot in this line, otherwise it will override the existing plot and we won't be able to see it. So this looks like to be a joint plot. In the x-axis we have the fair column, and in the y-axis we have age column. So let's start plotting this and then we will see. Here, as we see the signature of the joint plot, we need a data which is a data frame. Then we need to pass in the x column and the y column. Those would both be numerical columns. And then we have a hue as well, which could be used for categorical data, which will uh, plot different colors, which will plot the data in different colors for the given categories. Then we have a kind parameter, which is used for this internal plotting, how we want to plot the data. Here it is given as scatter, so it will plot a scatter graph for that. There are different other kinds as well. We could use a regression plot, or we could use a KDE plot. These are all different kinds of plots available. Then we have a height parameter, which gives the height of the plot in inches, and then we have a ratio of 5 given by default. This ratio means the width would be decided based on the height. And there are some other parameters as well if we want to use those. So let's check this graph and then we will see. So this is too big in size. What do is let's go back up where we define our global size, and we'll change this to 4 by 4. Run this, then run this once again. So what's happening here is we have an by default height parameter which is overwriting the global figure size object. What we could do is try to rechange the height, and that will adjust the width as well automatically using the same aspect ratio. Yes, now it looks a good size for us. Maybe we could make it a little bigger. Yes, so as you can see, we have our fair column in the x-axis, we have age column in the y-axis, and we in the graph looks similar. This is the distribution of the fair column, just the univariate data. This is the distribution of the age column, once again just the univariate data, and this is based on y-variate data between the fair and age columns. Next we have to plot this graph. This looks to be a univariate distribution, it looks to be a histogram just on this fair column data. So let's plot this first. For histogram, we'll use the histplot. We can also use this plot. We used to have a dist plot as well, distplot, but that has now been deprecated. And if you try to use this, Python will suggest you to use either distplot, displot, or histplot. If you check the signature, we need to provide the data frame and then either X or Y, just one of these. If you provide both, it will return an error. Then we do have a hue parameter given if you want to separate it for categorical data, but we won't be doing that here for now. And then as it is a histogram, we have the bins parameter as well. We will use that to see if the automatically created bins is same as this graph or if we need a different amount of bins here. And then we will also be using this color parameter to give the red color. So here this one looks to have more width than height. What I'm going to try is go back to our plt.rc params and change the configuration to 5,4. Okay, it looks a lot better now. So there are a couple of things. This is starting right at 0 and the x-axis is starting from negative here. So we will adjust that. And also the bins. If you see between 0 and 100, we have 1, 2, 3, 4, 5, 6 bins. Here between 0 and 100, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bins. So we'll try to adjust the bin size here. So here we have our 1, 2, 3, 4, 5, 6 bins as given here. The bins matches. Now we will adjust the x limb and y limb on x and y axis. For that we will use the argument plt.xlim and plt.ylim from the matplotlib. Now the graph looks similar. Here I can show you another thing. If you want to decrease the size of this uh, x and y level and all these numbers, we can set a context. I will go back up here. Just like style, we have some other options given in Seaborn as well. Just type set and press tab. You will get all of these options. We can go to context, press shift tab, and here we can set the context and font scale. Now for the context, we have four options. Those are paper, notebook, top, and poster. And as you go from paper to poster, uh, the text will become larger and larger given on what is the use of this visualization. If you are using it for a talk or a poster, you want those maybe the x level and y level and the data on the axis to be larger so people can see from far. Same with a poster as well. If you want to post it somewhere, you want people to be able to see those from afar. But if you are using just on the Jupyter notebook and you will uh, send the notebook over to somebody else and they can see it on the notebook, you can keep it smaller by using paper or notebook. Notebook is larger than paper, so here I will set the context to be paper. See, the size of this count and fair went down a little bit. We will now move on to our next graph, which is a box plot, and it looks to be plotted between uh, the class column and age column. So let's do that. Now we'll check what other parameters are available here apart from data x and y. Once again, we have view, but we don't need to use that. We have orient, which is by default given as this vertical. If you want to turn this into horizontal graph, you can use the h variable here. Then we have color and palette. Using the color, we will get the same color for all three elements. However, if you use the palette, you can use different color combinations which are given for matplotlib. However, one thing we have to note this: using palette without view is going to be deprecated in future versions of Seaborn. So we will try to use it for now. It will show a warning that it may not work in future versions. Then we have other parameters which you can go over as well. So let's start by plotting this graph and then we will make other changes. As you can see, we have our graph here which looks to be somewhat similar. This is between first and third quartile is between 30 and 50. This is looks like from 25 to 35, and this is just under 20 to 30 plus. This is just under 20 to 30 plus. So what we are going to do is we will use a palette. I think this is rainbow palette. Yes. So we get the same color combination and see the Python is showing a warning that palette without assigning hue is deprecated and will be removed in version 14. But we will keep it as it is for now. So what this graph explains is, this is a box and these extensions are called whiskers. So box represents the first quartile, that is 25 percentile level. This is the median line, 50 percentile level of the data, and this is third quartile, 75 percentile line. This is the 100% and this is the zero data. So the lowest data is here, the highest data is right here. And what you see, this dot markers here, those are outliers. So generally when plotting any data, there will be some values which will be vastly different from most of the given values, and they can, if you are calculating an average, they can change your average, which may not be representative of the overall data given, and so those will be excluded in boxplot. Now next move on to our next plot, which is a swarm plot. Once again, it's between class and age. So we basically have the same plot, just in a same representation, just using a different plot. And this color combination here is called set 2. So here Python is giving us a couple of warnings. The first warning is for palette, which has been deprecated. We will ignore this for now. The second warning is that because of the size, not all of the points had been plotted on this graph. If we just match the graph, it looks similar to each other. We have fair on the x-axis and edge on the y-axis. This swarm plot actually plots all of the data points on the graph, but because if it plots all 100% of the points, it will overlap, so it eliminates some of the points. If you want to plot those as well, you can increase the size of the figure. We could do this locally. Just type plt.figure and use the fixed size argument. So see, now we have a bigger object, but we still don't get all of our data here. So what we could do is, we can further increase the figure size. Let's make it 8. So now that second warning is gone and all of the data has been plotted here. Next up, we have to replicate this plot. This has 6 on the x-axis and count on the y-axis. So it looks like to be a count plot just for the 6th column. Here once again, you only have to use one of the x or y column. If you use both, it will return an error. If you use y in place of x, the graph would be horizontal in place of vertical here. So let's plot it. So we get our graph, just the color combination is different. For that, we can use the varieties palette. Here it looks similar. We can once again adjust the figure size. Figure. Yeah, it looks the same now. Next up we have a heat map. So heat map is a matrix plot. What that means is we need data in a matrix format, which could be achieved using a pivot table which has index with variables and columns with variables. If you check this data set right here, what we have is we have variables on the column, but on the rows we have the range index going from 0 to whatever. It says 0 to 890 here. What we need is variables on the range index as well, and to do that we can convert this into a pivot table, or for this figure it says the title of this figure says titanic.corr, which is method for correlation. So it is basically taking a correlation of the data set and using that data frame to plot this graph. So let's take the correlation first. TC is equal to Titanic data frame, and then we'll use the core method. Now let's see what happens here. So it threw an error which says could not convert string to float. So what we need to do is, what it is trying to do is to find correlation for all of the columns. If you check the signature here, there is a parameter called numeric only, which is false by default. We will convert this to true, turn this to true, and so it will uh, ignore all of the columns which doesn't have numeric, that is integer, and float data. So now we have the data in a matrix format. We have variables on both x and y axis, that is the rows and columns, and correlation is basically based on the data movement between these two variables. Survive versus survive will always be 1. Survive versus p class has a negative correlation. Similarly, age with fair, it has a positive correlation, but the value is not very big. So we have to plot this TC now. For the heat map, we can just use the heat map method. We have to pass in our data. We'll ignore the vmin and vmax for now. We'll use the cmap for this color combination, and you can also use anode. I will show you what that does, and you can take a look at the other parameters given here. So what vmin and vmax will do is to adjust this color combination based on the values you give. If you pass in vmin as minus 0.04, then this will be the minimum color here, and all of the data in this range will get this same color. Similarly for vmax, if you set it to 0.04, then anything above 0.04 will show the same color and there won't be any variation. So we'll let the Python automatically decide the color combination for us. We will just pass in our data for now, and cmap, which is cool warm, for this combination. So there you go. We have our color combination. Ours is little more brighter than the actual one. Uh, so there are a couple of more things. I will show you what anode. If you use anode is equal to true, then it will plot the data on each of these square boxes. Now here it looks very complicated and dirty, so we will remove it. But for simpler graphs, you can use that. And also in this one they have a title. If you want to put that, you can use plt.title method. So there you go, we have our title here, we have the graph. You can match, let's change the figure size as well. So as you can see, we have the same rows and columns: survive, B class, age, SIB, SP, Parch, fair, adult, male, alone, in the same order as well. So next up, we have to plot this graph here. What this is, it has age data for male and female. So it looks to be a histogram just for the age data, but the male and female category is separated. So normally we could just plot a histogram and use the hue argument if you want the same data on the same graph in two different colors for male and female. But what we have here is two different graphs. So this is just like subplots argument in matplotlib. For this we can use a facet grid here. Facet grid will just form a grid and then we can map on those grids for the data frame. Remember, the facet grid starts with capital F and it has capital G in the name. Then we need to pass in the data, what we want the rows and columns to plot, and we have a hue argument here as well, but we won't use that for now. Here we have only one row and two columns, so we'll pass 6 in the column. See what it does here is it passes in two empty grids for the sex, male and female. Now we can plot whatever graph we want here. We'll also adjust the figure size. So to adjust the figure size, we have the height argument and aspect ratio is 1. That means the width would be equal to height. For height, we can change height is equal to 2. If this is good enough. What we are going to do is, this figure size didn't work here. We have to convert this into an object and we will be plotting on that object using the map method. And what we are plotting here is age. So you need to pass in as a separate argument here. So we get our graph. The bins kind of matches to what is given here, but we want, this doesn't look very nice right now. We want a line to be at the top of the graph and at the end of the graph here, and then we also want to remove this little space. So what we'll do is we will define xlim here, which will go from 0 to 80, and then I will show you how to put the line on top and right as well. For the xlim, we have an argument here. We have xlim and ylim, which says none. If you go down and check this, okay, I can't find it here, but I did find an parameter for D spine, which removes the top and right spines from the plot. Those are the spines that end line. So I will convert this to false for now. So see, those lines are gone, and now I will try for X limb. So there you go. It looks nice now. This is a histogram for edge, and then it's separated by the 6 column as different arguments for column. So that's all for this video. Thanks for watching.